Learning Objective 5 from Section 6.3 is to make predictions using the regression equation and recognize situations when it would not be appropriate to do so. 16 college student volunteers each drank a randomly assigned number of cans of beer. 30 minutes later, a police officer measured their blood alcohol content, BAC, in grams of alcohol per deciliter of blood. The scatter plot is given below, and the regression equation obtained is y hat equals negative 0.0127 plus 0.0180x. Here's the scatter plot. From the scatter plot, you can see that our explanatory variable is number of cans of beer. That's our horizontal variable. And BAC is our response variable. That's our vertical variable. And you can see that there is a positive linear relationship. So we see an upward trend and a linear form. Part 1 says, if there is a significant linear relationship between cans of beer and BAC, is it appropriate to predict BAC for a college student who drinks 5 cans of beer? There are 2 things to check to determine whether it's appropriate to use a regression equation to make a prediction. First, there needs to be a significant linear relationship. This question says if there is a significant linear relationship, so we're told that there is. The second is that we cannot extrapolate. In other words, the data value that we are predicting for needs to be within the range of collected values for the explanatory variable. So you can see that these individuals, these college students, were assigned somewhere between 1 and looks like 9 cans of beer to drink. So as long as we are predicting within that range, it is fine to predict if there's a significant linear relationship. So in this case, 5 is right in the middle of that range of collected data, so we can predict. We'll do y hat equals negative 0.0127 plus 0.0180. 5 cans of beer is the value for x that we're going to use, so I'm going to plug 5 in for x in the regression equation. And then I can do this calculation in GeoGebra. I actually have it already entered in. So negative 0.0127 plus 0.0180 times 5 gives us 0.0773. There's our prediction. Let's move on to question 2. If there is not a significant linear relationship between cans of beer and BAC, is it appropriate to predict BAC for a college student who drinks 5 cans of beer? As we already stated, 5 cans of beer is not extrapolation. However, if there is not a significant linear relationship, then we should not predict. We only use the regression equation to predict if there is a significant linear relationship. Next. If there is a significant linear relationship between cans of beer and BAC, is it appropriate to predict BAC for a college student who drinks 11 cans of beer? Show your work to make the prediction or explain why it is not appropriate to predict. Notice that 11 cans of beer is at least 2 more than anyone in our data was asked to drink, and it may be that the relationship changes outside this range of 1 to 9 cans of beer. And so therefore, predicting for a college student who drinks 11 cans of beer would be extrapolation, and we should only predict for values between about 1 and 9 cans of beer. That's the range of collected values for the explanatory variable. So we should not predict for this situation either.